Okay, continued. So first step we're going to do for this problem is we're going to write out the equation again. HBr plus LiOH makes H2O and LiBr. It's already balanced. It says that we needed 5,000 milliliters, which is the same as, if we divide by 1,000, that's the same as 5 liters. So I'm just going to erase this and write 5 liters of a 1 mole per liter solution. So we needed to add 5 moles of LiOH to neutralize 2.5 liters of HBr. So for every 1 mole of LiOH, it neutralizes 1 mole of HBr. So 5 moles HBr divided by 2.5 liters. This would be a 2 molar solution of HBr. Now, if we think about it, we had to add twice the amount of the LiOH, of 1 molar LiOH, in order to neutralize it. Neutralize, half that amount. So it makes sense that it's double the concentration. So essentially what was going on is you had this mystery amount of hydrogen ions, and you had to add hydroxide ions until it was neutralized, and then when it went 1 hydroxide over, then it turned pink. And you measured how much that took in order to do this calculation. And these steps are just taking us through the steps that we just did. So let's actually do a little shading here. So step 1 is write out the equation. Check. Step 2 is multiply the liters by the molarity in order to determine the moles of LiOH that you had to add to neutralize. Step 3, use the mole-to-mole ratio to determine how much HBr must have been present. Step 4, divide the number of moles of HBr present by the number of liters to determine the unknown concentration. Oh, and did I do this without even reading it? Pretend that 1 H plus represents 1 mole's worth of H plus ions, and 1 OH minus represent 1 mole's worth of OH minus. Draw out this whole titration process with pictures step by step. I kind of did this, but not exactly. So draw a burette with a bunch of OHs in it. Okay. And draw a flask with the appropriate number of H plus ions. So it's 2 molar, so there's 2 in here. Then draw the equivalence point moment when the number of H's is equal to the number of OH's. Be sure to indicate how much base has left the burette. So let's see. This OH goes here. This OH goes here. So we've added 2 moles of the lithium hydroxide, and it's just a 1 molar solution. So that's why we had to add double the amount of volume. And then you add just 1 more, and that's when it turns pink. So you can visually see when you've reached the end point. Okay, so I actually did this next part in the video here. So again, if you haven't watched this or rewatch it now, I actually measured out 15 milliliters of H2SO4. That's an unknown concentration. So 15 milliliters is the same as 0.015 liters. Okay, and here are my burette readings of how much base was initially there, and then how much base was there at the end. They read from 0 to 50, so kind of backwards. So I'm going to subtract here. So I'm going to do 33.2 minus 6.9. And that's 26.3 milliliters. Okay, so let's show our formula. H2SO4 plus NaOH makes H2O plus Na2SO4. So then I'm going to put a couple of 2's to balance this. So it's a 1:2 ratio of this acid to base. So let's write underneath exactly what our amounts are. So remember, we started with 0.015 liters of the acid, and the base's concentration was 0.1 molar, and we had to add how many liters? That's 0.0263 liters. So times 0.0263 liters. That comes out to be 0.00263 moles of NaOH were needed to neutralize that acid. Okay? And then our multimole ratio for every 2 moles of NaOH, there's only 1 mole of H2SO4 since each molecule has 2 hydrogen ions. So I'm going to divide 0.00263 by 2. That's 0.001315 moles of H2SO4. And then to get the concentration, I divide by the 0.015 liters. And my final answer is it must have been a molarity of about 0.088 molar H2SO4. That's the mystery concentration. So there you go. That's how you do the calculation piece.